Okay, welcome to part 2 of my CoCo3 operating system. And last time I showed you the overview of what's going on, and this time we're going to show you some actual interactivity provided by my fourth shell. Give you a little bit of fourth primer, not much though. So here we logged in and we see we have our legs forth, and rather than run a demo this time though, we're going to enter the words, oops, which didn't take for whatever reason. There we are. Okay, this is a list of all the words that we can use interactively in forth or group together and make new words out of. A lot of these are kind of standard stack programming language type stuff. You'll see at the top, right around here, we got our demo. That's my demo, and down at the bottom we have some of our system. This is forth words that tie into actual system calls into the operating system: yield, sleep, spawn, system exec, get channel, put channel, you know, all the different channel things. A lot of channel things. Remember, the operating system is pretty much dealing with channels. And kill, to kill a task, stuff like that. Some of it works, some of it doesn't, be honest with you. And up toward the top here is some more of the higher level definitions. And the one we want to look at is dir. Dir does exactly what you think it's supposed to do. We're going to type dir, and that'll cause it to execute. We're going to give it a path name, which is going to be root. And we hit enter, and we're going to get a list of what's under the root directory. Now, when I say directory, this is actually coming from a name server. The name server is basically, think of Windows registry, where you can tie names to values. What you do with the values is up to you, but the idea is it gives you a way to organize and find channels and tasks and whatever's in a systematic approach. So tasks that essentially when they start up, they don't know anything about their environment until you do this. And this is a good way of doing it. So we can see under our root directory of the master name server, we have a directory here called chans. As I know it's a directory because its attributes is 1. And that's all our pre-existing channels. Don't worry about this right here. This is actually its value, which is not very important for directories, to be honest with you. So we're going to use the same directory, and we're going to pull up a directory of the channel directory. And here's some predefined channels we have. These are actually been defined by servers running in the background on this operating system. And probably the first one here that should be addressed is the master name server has a reference to itself. So we can open up this channel right here. This is actually its channel number. And we can take and put that, if we open up that channel number there, we can actually talk to the master name server and query for names. The master name server is actually not part of the kernel. It's actually a user space program. It communicates on all the channels just like the rest. The master name server just exists to be able to let our tasks find other directories or find other tasks and files. That's the master name server. Why it has a reference to itself is probably not really necessary, but it's just one of those things. Another interesting server is right here. This is a channel called the DriveWire serial server channel. Again, you query this in a message reply type format, and you basically ask it to open up DriveWire channels for communicating on and close DriveWire channels. This is how we basically were able to telnet in to the CoCo, is because of this guy right here. Well, technically there's another server that actually handles the incoming connections, but it uses a lot of this super server here to be able to handle connections. And one of the connections that's opened up by yet another server is this MIDI channel here. And of course the MIDI DriveWire comes with a MIDI channel on channel 15. So I have a server task running that opens up that and then makes a channel to communicate on. It basically reads bytes from this channel and sends them off to the drive wire channel. You don't see the drive wire channel here because it's basically unnamed. You don't actually have to name your channels. They can be named or unnamed, kind of like pipes are in Unix. And this is how a task, basically these directories are how a task actually finds other tasks, and you register when you make a channel, or if you make a task that's of importance, you can name it and add it to the registry. This registry is sort of like a proc file system combined with Dcache in Linux. Not really sure where this is going, but it seems to come in handy for what I'm doing right now. So let's look at so that's the name server, and dir is how we interact with the name server. There's not much to it. There's no I never really had any of the tasks register themselves, so there's really nothing to see there. But I'm going to take a look at some code I wrote. I'm going to slide a window over here, and we'll look at some notes I wrote to play around with that MIDI port. And you see that first thing we have is a variable right here. This is all Forth code, so it's not really important that you quite understand everything. But the idea is this word right here is basically just creates a variable. And this init MIDI word basically queries the name server for channels MIDI, and when it receives the channel number, it assigns it to this variable. So now that variable is set with the channel number. We don't have to query the server, because querying the server is actually pretty slow. And when it sets it, this line right here basically sends some control information over to the MIDI channel to change the instrument from a piano to some sort of organ or something, or string ensemble or something like that. And that basically sets up our MIDI. Next we have a couple notes to basically send the MIDI information over to the MIDI channel to turn a note on, turn a note off. And we can group those together to create a chord. So we can turn on we can turn on note 20, note 24, and note 27, which gives us a major chord. I think it's like E major or something is what it plays. And chord off does the same thing. It turns the notes all off. And we also have one for percussion. I was interested in seeing what kind of percussion sounds the MIDI channel has. It doesn't have a whole lot of them actually, but so these are these words that were actually this source code right here is compiled right into the shell. And of course it's not meant to be there permanently, it's just meant to be kind of show you sort of how it works. And let's list our words again in our demo. And we have here's those words that we defined in our Forth source, and here they are listed right here. So we're going to play around with them. And the first thing we need to do is actually initialize the MIDI port. So we're going to type in init MIDI. We're going to run that word, and it doesn't do much. This Forth does not have prompting. Usually Forth has like an OK prompt telling you it's ready to accept input again, but my Forth doesn't have it, and probably doesn't really need it, to be honest with you. So we're going to test our new words that I incorporated in, and we're going to go chord on, and you should hear some stuff come out of the speakers here, I hope. Okay, that should be loud enough for you. And that chord actually will keep on playing until I issue the chord off command. So we have a way to turn this very ominous sounding major chord on, and turn it back off again. So you see that we're actually interacting with the, we're sending channels. Let me do a directory here. We're actually sending MIDI information to this channel in a standard MIDI format. There's a server that's getting that information and putting it over to the drive wire channels, and behind that there's a drive wire server that actually is getting that information, actually putting it over the drive wire channel over to the MIDI synthesizer via drive wire. So there's a couple programs in the way there, but they're basically filters and that type of thing. So what's cool about the interactive Forth is that I can simply make a new word like that, and now everything I type will actually be compiled into this new word test. The colon just tells the forth to create a new word called test, and then we can simply do cordon to turn the cord on. We'll sleep for about 2 seconds. That's 80 hex ticks, and we're going to turn the cord off. And just so we know that what's going on, I'm going to actually print a string. This is how we print a string in Forth. It's kind of clunky. There's easier ways of doing it, but I haven't written that part of the Forth yet. It's not really important for what I'm doing. And when we're done, we use a semicolon to tell the Forth compiler to stop compiling and go back to immediate mode. So now we've just defined all this stuff here is going to be done when we type the word test. So now we're going to test it and see how she does. And it didn't work at all. And I don't know why it didn't work. Sometimes this compiler gets a little wonky. Yeah, it looks like it farted out. Sometimes the drive wire server farts out too, and I just lose my connection. So let's try that again. Yeah, something went wonky on that. So we'll just have to relog back into the server, and we're going to have to make that word again, so I'll do it real nice and fast. Cordon 80 sleep, cord off, string done, type CR. Sorry about the foobar there. Like I said, stuff's not exactly working yet. There we go. Okay, so now we listed our words, and you see now that the new word I defined up here, test, is now in the thing there. Is in the list of words, and now we can run it. Oh, I can't run it yet. That's going to fail. I forgot to initialize. Okay, so now we're logged in on virtual port 3, so... okay, we'll do this nice and fast. Cord on, 80 sleep, cord off, and we're going to skip the done message. Well, yeah, we'll do it. Okay, done. Type CR. And there we go. And I forgot to issue edit MIDI, which will get really screwed up. Yep. Sometimes the drive wire has problems. I'm not sure why. Okay, that probably worked. Sorry, not seeing the best part of the inactivity, but... And there we go. We defined a new word using Forth. This is principally why I like to go to Forth. It took me literally 10 minutes to port this old Forth I wrote for the 6809 to get it into my operating system, and it took me another maybe a half hour to create some system words here to actually tie into the kernel that it's sitting on. Everything else is pretty generic. So you can see where the Forth works pretty good. And so you can know that it's actually interactive, I'm going to show you it's scrolling, if I can figure this out. Give me a second here. I should be able to pull up another terminal. Might get a little funky here on you. Okay, we're going to pull up another terminal. Localhost 6809. So we're going to create another session, and of course this is all... Okay. So now we have 2 sessions going on, one in virtual port 4 and one in virtual port 3, and let's have it do some things all at once. So, and you can see we're actually printing the words 3 times to each terminal. It's working separately. And if I go back to this guy here, I can still issue test and get my ominous chime. So that shows you a little about what it can do. And I'm running kind of overtime here, so I will let it go at that. There's still some other stuff I can show you, but not too worried about it. Thanks for watching.